We're going to do design thinking and come up with our own idea for a native application that runs on a mobile device.
Trying to look at how bumblebees interact with one another and trying to model their social interactions using mathematics.
We need more girls in computer science. Please come join us.
WFSU Public Media's STEM Adventures are brought to you by Atkins and FSU's National High Magnetic Field Laboratory.
3, 2, 1, go!
I'm okay.
Since 2006, WFSU Public Media and the National High Magnetic Field Laboratory at Florida State University have held summer camps for young women interested in science, technology, engineering, and math, also known as STEM. Based on the national PBS program called SciGirls, these hands-on experiences at a variety of locations around our community have encouraged many middle and high school girls to consider and pursue careers in STEM fields. Over the years, the camps expanded, adding more girls and more adventures. But this year, COVID-19 changed the plans for 2020. Now, instead of heading into the field to learn and experiment, we're bringing STEM adventures to you.
SciGirls rocks!
I am so excited to have Dr. Yolanda Rankin with us today. Dr. Rankin, thank you for being here, and could you tell us a little bit about yourself?
My name is Yolanda Rankin. I am an assistant professor in the School of Information at Florida State University. My PhD is in computer science, so I am a computer scientist by training. How did I end up in the field of computer science? Well, short story, I was originally a mathematics major in undergraduate school. And so I come from the state of Mississippi, small institution of historically Black college known as Tougaloo College. And at that school, they didn't have a computer science department, but they had a minor in computer science. And I took a programming class my freshman year, and I loved it. And so this created, I guess you could say, energy and drive and passion for coding that once I finished my undergraduate degree, I decided to explore it as a degree for master's in computer science. And that led to a whole new career opportunities that I could never have imagined back when I first started undergraduate when I was 18 years old. So that's sort of the short story of it, but yes.
Great. So how do you explain to the general public what you do for your career?
Good question. So the way that I like to think of myself, I care about that intersection between technology and people. My specific area of expertise is human-computer interaction. And I'll stress that, human-computer interaction. So I care about that intersection where people use technology to solve some of society's most pressing problems. In my specific research lab, we look at how technology can solve issues such as broadening participation in computing, meaning that there are groups of people that are typically not represented in large numbers. And one of those groups happens to be Black women. I am a Black woman. And of course, that is relevant because women overall are underrepresented in the field of computing. And so this is something that SciGirls would care about. I care about all women being represented, and I also care about Black women also being represented in this space. So one of my research projects is looking at ways that we can devise pedagogy. And so those are learning strategies to help ensure that women come into these intro level computer courses and they can excel and feel like they belong in this space. And believe me, women belong in computing. And so I'm a huge advocate of that. And I do a lot of research in which I look at ways in which women have strategies for coping and surviving those tough courses, because let's face it, not everything is easy, but you got to get through it. I look at ways in which we have mentorship and those practices that allow us to effectively help others through those tough times. I also look at ways that we support one another. And so these strategies can involve everything from social networks and use of social media to also having a network of role models that can guide you through not just the aspects of learning, but also how to navigate professional development, how to develop your soft skills, your leadership skills. All these things are important. So when people think about computer science, or computing is a term we can use more broadly, it's not just about coding. So now I'm going to take you back to that piece I first started out with about human-computer interaction. So one of the ways that I combine my interest in, of course, getting women to participate in broadening computing is having them to be the ones to conceptualize how can we design technology to fulfill a specific need. So one of my areas is gaming. And I looked explicitly at how students can come up with ideas for the kind of games that want to influence them to want to learn, to be excited about learning. And one of our projects is looking at games for language learning. And so I've been working with groups in the local Tallahassee area to understand what kids think about games, because we all play games, right? We play board games, some play video games. I help them to be creative and think about, if I want to learn, say, how to speak Spanish, how might a game help me to do that? And so they are involved in every aspect of that game design process. They come up with these ideas, they put them on paper, they act them out, role play, how the game interactions would be, the learning activities, they choose the words for vocabulary in Spanish, and before you know it, eventually we have a prototype. And so a prototype is not necessarily something that you would necessarily play on your phone or on your computer, but it's a paper-based version of that game. You can think of it like a board game, if you will. We build it out, they play the game, they test out the rules, they see if they make sense, they play around with ideas about character or the story. All of these are required to create an interesting game that hopefully helps you learn Spanish. And that's just one of the projects that I do.
I love that. I love that the youth are designing it and have the agency. The next question is, how did you first become interested in, you said women are underrepresented, Black women are underrepresented. How did you become interested in computer science or computing?
So I'm gonna go back to that first class. I came into undergraduate school, by the way, undecided. I loved everything. I'm probably what you call a lifelong learner. You show me something, I'm like, oh, that's interesting, and I'll dibble and dabble. But in this particular class, the instructor was introducing us to Pascal. So this tells you how old I am. I'm very old. But Pascal was the language back then. And so in this class, we were tasked with writing our first programming language. And several of us were in the lab. I mean, we were in the lab like after midnight, and we could not get our code to work. And code, think of that as lines of instructions in a particular programming language. In this case, Pascal's the programming language. We couldn't get it to work. So after struggling, we went and sat down with the instructor, and we said, oh my God, this is not working. We were so discouraged. And she actually taught us how to think through line by line what our code was actually doing. We call that tracing your code. And as a result, I began to go, oh, this is very logical. I'm a logical person. I like this. This makes me feel good. And I think I can do this. And so I took more and more programming courses. And remember that my institution did not have a CS major, but I minored in computer science, and the math was really important because it helped me to be a better student in the computer science class. That logical thinking again, thinking through. So I ended up majoring in mathematics and minoring in computer science. And that's really how I fell into it. It was a nice match. That was me playing around, of course, and liking it. So that's how I discovered it.
That's awesome. So the next question is, what advice do you have for middle school and high school girls who might be interested in computer science or just STEM in general?
I say, do not sell yourself short. You have a lot to offer. And I say that because you sometimes think that because you're only 12, 13, or you're only 15, 16, that you're like, oh, I don't really know what I'm doing. That's the process of learning. We all find ourselves an expert. In fact, I still feel that way today. And I've been doing this for more than 20 something years, but that's a good thing. You have a lot to offer. Your ideas are valuable. So just invest in the fact that you have something to offer and believe that and follow through with that. And so don't be afraid to express your opinions and your ideas. You have a voice, and we need that voice more now than ever, especially in fields of science and technology where we're not represented, because it's those voices that actually spark creativity, innovation. And I say that those are sparks of genius. And we all have that within us. And I want to see more women express that and use that. That's my advice.
Wonderful. I love that advice. That's the end of my questions. Is there anything you wanted to add or any closing comments that you have?
We need more girls in computer science. Please come join us. I also want to say this one thing. Computing is more than just coding. I know that for some people, this can be a scary idea. Some people love it and they gravitate towards coding. My work, I say game design because I'm not heavily invested in coding. Yes, I can code, but my interest lies in, again, people in technology and designing those technologies. So if coding is not your thing, that doesn't mean that computer science is not for you. It simply means that that's just not the specific area. We have a range of things you can study: cybersecurity, networking, artificial intelligence. So not everything is about coding. So explore, get out there and see what we have to offer. And you may just find that there's something in it for you. So those are my last words.
Thank you so much. And thanks for joining us today.
Thank you for having me again. And I wish to see more and more women in computing. Awesome. Thank you.
Hello, Sci Girls. I'm Chris Womack, and I'm the Manager of Creative Development at Florida Center for Interactive Media at Florida State University. And today we're going to be doing an activity. But first, we need to go to the office to get some supplies. So let's go. Here we are at the Innovation Park, Research Building B, at Florida State University, which is home to the Florida Center for Interactive Media. And we're just up the road from the world's most powerful magnet at the National High Magnetic Field Laboratory, also known as the Mag Lab. How cool is that? Okay, Sci Girls, so let's go into the building and find our supplies. Come with me. Okay, Sci Girls, we made it. We're at the headquarters of FCIM. Let's go talk about some of the work we've done. For over 20 years, the mission of our center is to develop custom technologies and media to help people access information and expand their knowledge. The custom technologies that we develop for our partners include websites, databases, online courses, and native applications that run on mobile devices. Right now, I'm standing in front of a 20-year timeline that captures most of the work that we've done over the years. So since we're here at the office, let's take a quick tour. For today's activity, we're going to do design thinking and come up with our own idea for a native application that runs on a mobile device, such as your phone. We're going to use common materials that you find at your house, such as colored paper, glue, scissors, markers, things like that. This is what we call paper prototyping, and it's one of the first steps that we take in our design process when we start a project. It's a great way for us to get our ideas from our head down on the paper very fast, and we can then share our idea with others and get good feedback. Before we start this activity, let's do a quick exercise to get us thinking like a digital designer. Take a minute to think about the current applications you are using on your phone, tablet, or computer. Write down some of your favorite features about these apps. Do they help you see and better understand the world around you? Do they help you stay connected to your family and friends? Are they easy to use without any directions? Now write down some things that you don't like about these apps. What improvements would you like to see made? What types of features would you like to see added to make this app even better? Do you have an idea that you wish would be available on your app? Now is your chance to come up with an idea, prototype it using paper, and share it with others. If you still can't come up with an idea for an application that you want to design today, we've included a download packet with some prompts to help you think about an application that you want to develop on paper. Also included in the download packet is a document that has 3 phones on it so that you can sketch some ideas down before you get to doing your paper prototype. And the end result should look something like this, where you quickly sketch your ideas down and you got a detailed map as to how you're going to do your paper prototype. We have a more detailed phone that you can print out that allows you to cut out all your pieces of paper and all your ideas and put it together on a printout that looks just like a real phone. So here I have a paper prototype for an idea called Pet-O-Meter. And this application tracks the activity and how healthy my pet is. So at the top of my home screen, I have a logo called Pet-O-Meter. And further down the screen, I have a window where I can select which pet I'm going to take on a walk. And then when I've found the pet that I want, I'm going to click Go. And in this case, I have selected my pet walrus to take on a walk. So I have the picture of my pet walrus at the top here, along with his name. And then further down, I have a window that shows all the walking activities I've done with my pet walrus. And when I'm ready, I click the walk button at the bottom of this screen to start my new walk with my pet walrus. So on my third screen, I have a display of my current walk. Again, I have my pet name, and then I have a little dialogue that shows how far we've walked and the time duration. And when I'm finished with my walk, I'll click stop. And then we'll go back. My pet's home screen, where our new log will be logged into this window here. So this is an example of a paper prototype that you can design and share with your friends. Okay, Sci Girls, I hope you're having a good time paper prototyping your new native application idea. And be sure to take a video of you presenting your paper prototype so that you can upload it and share it with your other Sci Girl friends. And I hope you have a wonderful summer and enjoy all the other activities you're doing in your summer camp. Bye!
Hi, I'm Nia Terry. I'm talking with fellow Sci Girl, Monty McKinney, who's a mathematics major at Spelman College. Hi, can you tell us more about what you're studying in school right now?
Sure. So I go to Spelman College, like you said, it's in Atlanta, Georgia, and I'm a math major and Japan Studies minor. But focusing on the math, basically, I'm learning how to apply math to different systems in the world, how to use math as a tool to understand different kinds of science and different phenomena that happen around us.
So I'm understanding that right now you're learning about bees at Spelman?
Yes, I'm actually doing a research project right now with one of my biology professors. I actually came in as a biology major, but I switched to math. But basically, I'm trying to look at how bumblebees interact with one another and trying to model their social interactions using mathematics.
How do you monitor social interactions with mathematics? Like, how do you?
That is a really good question. So there's a lot of research out there already on honeybees. And basically what these insects do is, since they live in hives of like up to 1,000, 10,000 individuals, they really have to communicate with one another to know what's going on in the hive and what work they need to do to keep the hive running properly. And so honeybees, they're actually able to exchange information by doing these kind of weird mouth-to-mouth kisses where they actually exchange pollen and honey through that. And by that, other honeybees can say, okay, well, this honey tastes really good. I'm going to go to that flower, and I'm going to go to this food source over here, or maybe this area needs some work. So they actually do like this literal exchange of information by exchanging what's in their mouth at that time.
I understand that you went to Spelman as a biology major, but not a math major. So as for Sci Girls, how did that make you think about a career in STEM, not just in math, but in general?
I think Sci Girls really helps because Sci Girls introduced me to lots of different scientific fields. And so if I hadn't had Sci Girls, originally I actually wanted to be like an electronics engineer way back when I was in Sci Girls. But through Sci Girls, you know, through the water testing at the pond in the back and doing all these other activities, I was really able to learn that there are more scientific fields out there, and there's really just so much that you could do. You can do whatever you dream of. So I came in as a biology major, and knowing that there was so much out there, I knew that I didn't necessarily have to stick with one thing. You know, you can really just explore and see what you like and see what attracts you within different fields. And I just really liked mathematics. So I was like, okay, well, I'm just going to go to that major, and I'm really enjoying it. So I'm glad I switched, and I'm glad I knew that I didn't really have to just stay on one track. I could just explore.
In your career, there have to be challenges with being, you know, a scientist, with being an engineer, with being a mathematician. There's always challenges. What's the most challenging thing that you've had to overcome?
I think the most challenging thing I've had to overcome is learning that you don't have to do everything by yourself. Specifically with mathematics, you know, everybody struggles in math. It's just a really hard subject. And the farther you go, the harder it gets, actually. So it's really, you know, in school, you feel like, well, if I don't understand this one thing by myself, then what's the point? Like, I need to learn to do it by myself. I need to understand it, and then I'll be fine. But really, when things get harder, it's best to just reach out to other students, to professors, to tutors, and just say, can you help me understand this? Because sometimes it's really, you need that extra push or that extra perspective from someone else to really understand it for yourself. So it's not a bad thing to ask for help. You just have to, you know, work at it and use what other people can help you to do to actually understand it. And yeah, together makes it better.
What would you say to your high school self, I guess? You know, if like before you went to college, everybody says it changes everything. To your high school self when you were first walking in as a freshman, what would you have said to yourself?
I think I would tell high school my auntie not to worry so much. Don't sweat the small stuff. I had a habit of getting so worked up over the smallest assignments or the smallest grade point changes on my test. Like if I get marked off 0.5 on a question, then I'm going crazy about it. But I think it's not that serious. I would tell myself to relax, to just take things as they come, to enjoy time in high school before you get to college because stuff gets harder. So really enjoy the time you have at home with your family, all of that. Don't worry so much.
And with your degree, what is your final goal? What is your ultimate goal with your degree?
I would like to continue doing applied mathematics research. So I definitely want to use the math that I have and apply it to different biological systems like I'm doing with the honeybees. And yeah, I'd like to continue doing that, I think. Just working on research that can help us understand the biological world around us.
Thanks for joining us.
Of course. Thank you for having me.
WFSU Public Media's STEM adventures are brought to you by Atkins and FSU's National High Magnetic Field Laboratory.